from our investigation with Desmos, we found that if we had y equals sine x, then its derivative is just the cos x. And if we have y equals cos x, its derivative ends up being negative sine x. So if you forget, just think back to what the original graph looks like, where the max and mins are. You know you'll have zeros for your derivative, and so on from that. So our examples here are to differentiate. So find the derivative. Now, if this first one was just f at x equals sine x, it would be easy. It's just going to be cos x. But because it's a 3x, it's actually a composite function. So our f at x really is, we could do g at h at x. Okay, and the inner function, the h at x, that is the 3x, and the g at x is really just our sine x. So we need to apply that chain rule here to find the derivative of f at x. So looking at that, remember the chain rule just says the f prime at x will be the derivative of the outer function, g prime, at the inner function, times the derivative of the inner function. So this is what we're looking at using here. So the derivative of the outer function, the derivative of sine x, is going to be cos x. So f prime at x is going to equal cos, but it's not just x, it's the cos of the inner function, cos of 3x, times the derivative of the inner function. The inner function is the 3x. We're going to multiply that by the derivative of that inner function. Now, your back of the book will likely put that constant 3 in front because it's the cos of 3x being multiplied by 3. It doesn't mean the cos of 3x times 3. It's the cos of 3x multiplied by 3. So just be clear on that. All right, the second one here, I have a constant out front. So when I take the derivative, my derivative, I can just look at the derivative of this piece, the cos of 4x plus 3, and just multiply it by that constant. And again, we have the chain rule happening here. My outer function is cos x, and my inner function is 4x plus 3. So the derivative of the outer function, I'm just going to keep that constant 2 out there. The derivative of that cos of x, or in this case it's 4x plus 3, would be negative sine at the inner function, 4x plus 3. And then that has to get multiplied by the derivative of the inner function. And the derivative of the inner function would be just a 4 there. Now I'm going to tidy that up. I have 2 multiplying negative 1 multiplying 4. That's going to give me negative 8 times the sine of 4x plus 3. All right, next. We have y equals x cubed times the cos of x. So this actually involves the product rule. So product rule says the derivative of the first times the second plus the derivative of the second times the first. So my derivative, the derivative of the first, the derivative of x cubed would be a 3x squared times the second plus the derivative of cos x, derivative of the second, negative sine x, times the first. Now I'm going to work on factoring this. This does have a common x squared, and that's going to leave me with 3 times the cos of x minus an x times the sine of x. And again, I just pulled not the constant, but that variable into the front so it doesn't get confused and people change that to an x squared, because that's not what that actually would be what we would intend there. All right, next we have the tan of x. We didn't look at the Desmos version of tan x and estimate what that derivative was going to be. So we're actually going to develop this by using what we know about tan x. And we have a property that we learned in grade 11 that it's called the quotient identity. The tan x is the same thing as sine x divided by cos x. So now we have a quotient, and we can apply the quotient rule here. If I apply the quotient rule, we are taking the derivative of the top, so the derivative of sine x is cos x, times the bottom, minus the derivative of the bottom, derivative of cos x is minus sine x, times the top, and that's all over the bottom squared. And that's going to be cos. So when I want to square that bottom, remember the square goes here, so that it doesn't look like I'm squaring just the x. I want to take the cos x and square it. Now I'm going to simplify that here. We've got cos squared x, because we have cos x times cos x. Cos x times cos x will give us cos squared x. And then take away a negative becomes plus, and then sine x times sine x will be sine squared x, and that's all over cos squared x. And then on the top, you might remember that as the Pythagorean identity. So cos squared x plus sine squared x is just equal to 1. So that's equal to 1 divided by cos squared x. And that is a reciprocal identity. That's equivalent to secant squared x. So there's different ways you can see the tan of x being written when you find its derivative. All right, example number 2 here, we are going to determine the equation of a tangent to this function, 2 times sine x cos x, where x is pi over 2. All right, let's see what we can do with this. We know to get the equation of your tangent, it's a line. It's going to be y equals mx plus b. And we know we need the derivative of f at x to get the slope of any tangent at x, at any point x. All right, again, we've got this constant in front, so the constant just stays there. And then I've got 2 functions here. I've got sine x and I've got cos x. So product rule makes sense here. I want the derivative of the first. So the derivative of sine x is cos x times the second plus the derivative of the second. The derivative of cos x is negative sine x times the first. And then I'm going to tidy that up. So we're going to have 2 times cos squared x. Oh my goodness, look at that. I think we've already done this question. I feel like it. Plus, oops, that should be a minus. Sine squared x. Oh, it's different though. It doesn't have the plus in between. So we don't have Pythagorean identity there. But this is the derivative at any point. We want the derivative, or the slope of the tangent, when x is pi over 2. So pi over 2 is just your 90 degrees there. We want the cos of 90 degrees. So if you think of your graph of cos starts at 1, goes like that. At 90 degrees would be right here, the cos of pi over 2 would be 0. So this is going to be 0 squared minus, and then if you think of your sine curve, at pi over 2 is right at the 90 degrees, it has a value of 1. So that's going to be 1 squared. So that's going to be 2. Take away 1 squared, which is negative 1. Because I'm not squaring the negative, I'm taking away, and then the sine of pi over 2 is 1, which gets squared. So that's going to be a negative 2. So I know my slope is negative 2. So m equals negative 2. And I need my point. I need to figure out f at pi over 2. I need the y-coordinate at pi over 2. The sine of x at pi over 2 was equal to 1. And then the cos of x at pi over 2 was equal to 0. So that's equal to 0. So my point, my coordinate that I'm going to use with y equals mx plus b would be pi over 2, comma 0. So now I'm going to get the equation y equals mx plus b. I'm going to have 0 for my y. My slope is negative 2. My x is pi over 2 plus b. Negative 2 times pi over 2 is equal to negative pi. So my b is equal to pi. So therefore my equation of the tangent is y equals negative 2x plus pi. And there we have that one.